to calculate the number of moles in a solution, we have to use a different equation to the one that we used before. Okay, so for a solution, we use the following triangle. Moles is at the top this time, and we have concentration and volume. So for a solution, to calculate the number of moles, you have to times the concentration of the solution by the volume of the solution. As we're going through this, I will just shorthand it. So N equals CV, which would mean that our triangle over here is number of moles over concentration times volume. Okay, now the important thing to note here is that volume is always in litres. However, when you're working your way through these problems, you'll notice that quite often the volume is not given as litres in the question, so you have to convert it. Okay, so if your volume is in millilitres or centimetres cubed, then you must divide by 1,000 to get the volume in litres. So just a wee shorthand there for you to remember. Okay, so if we go back to that triangle then, number of moles over concentration times volume. Number of moles we know for a fact. Units are moles or MOL, up to you what you want to use. The volume is in litres, okay, and our concentration is therefore in moles per litre. Make sure when you're writing this out that you're not putting this wee -1 on this, because that would mean per mole, not mole per litre, so just be really careful with that. There is a space in between these two. Okay, so let's have a look at a few examples of how we would use this triangle. The first way to use this new equation is when calculating the number of moles. So for this question here, it asks how many moles of sodium hydroxide are dissolved in 100 centimetres cubed of water to make a 2 mole per litre solution. So the first thing we can do, we can draw our triangle. Okay, we know that number of moles is what we want. Our concentration we have here 2 moles per litre, so we've got our concentration, and our volume is 100 centimetres cubed. Okay, now we know straight away that we're going to have to convert this volume into litres before that we can actually do the calculation itself. Okay, so 2 ways you could do this. You could do it all in 1 step, or you could do it in 2 steps. So we'll do the 2-step method first. Okay, so N equals concentration times volume. Over here we can do the volume, we can look at the conversion. Okay, so 100 centimetres cubed divided by 1,000 will give us our 0.1 litre, okay, for our volume. We can then come back over here and substitute it back in, so you can do 2 moles per litre times 0.1 litres, and we get our final answer of 0.2 moles or mole, up to you again what you use for the units. Now I'm perfectly happy for you to do it this way and lay it out in your jotters like this and have the 2 different steps, or I'll be honest, I tend to be a bit lazy and I just do it all in 1 step. So when it comes to this point, I would just go straight to N equals CV, put my 2 in for my concentration, and at this point you're just amalgamating, you're just pushing this step onto the side here. If you're not so confident with doing the maths in your head, make sure you've got yourself a good calculator that you can use. Try not to use your phone calculator because it doesn't always work well. Okay, and make sure if you are doing this in your calculator in one step, you're putting these brackets in, otherwise you're going to get 2 times 100 divided by 1000. Okay, just make sure you're putting the brackets in every time. For this one it's okay, but when we move on it'll get more complicated. Okay, and then again we've got 0.2 mole. And that is how you use this new solution triangle to calculate the number of moles. Moving on to example 2, calculating the concentration. Calculate the concentration of a solution of copper chloride if 2 moles is dissolved in 500 centimetres cubed of water. Again, first thing I'm going to do is write out my triangle, or you could write it out like this, it's up to you. Until I remember it, I'd be writing that out every time, so you're not going to make a mistake with your formula. I'm interested in calculating the concentration, so I know that my formula is going to be N over V. Looking at the question here, I can pick out N straight away. N equals 2 moles. And my volume this time is 500 centimetres cubed. Again, we have to divide that 500 by 1000. So now our answer becomes 2 divided by 0.5. Oh, off page. Okay, which means that my final answer is going to be 4. Okay, remember for concentration your units are mole per litre. And that's how you do that one. If again you want to separate it out and do this volume step over at the side, so do 2 calculations, that is entirely fine with me. I don't have a problem with that. Okay. Moving on to the last way that we can use this equation, we're looking at calculating volume. So what volume of water is needed to prepare a solution of copper chloride of concentration 0.5 moles per litre using 2 moles of solute, and again our solute here is our copper chloride. Even if you're not drawing out this triangle every time, which you don't have to, please make sure that you're actually showing your formula, what you're using. Okay, so we're looking at volume, so it's going to be V equals N over C. If you don't have that first step, how am I meant to know where you're substituting your numbers in from? Okay, so be careful, make sure you're showing that. Number of moles, 2. And our concentration is there, it's in the correct units, 0.5, so that's a nice easy one. So 2 divided by 0.5, and that will give you 4 litres, and that is your final answer.